In this demo, we're going to go ahead and take a look at how we can access a persistent data store in Node.js. And the persistent data store that I want to use is MySQL. And if we're looking at MySQL, I'm just going to show you what it looks like on my machine. So I'm going to go into a terminal and I'm going to type in my username and password. And I'm going to show my databases. I'm going to look at the to-do database, so use to-do. And then I'm going to show my tables. And I have a tasks table. If I do a select star from tasks, I have some data in my database. Okay, so I have kind of like your project, I have a tasks table that has information about an ID, a description, whether or not it's complete, a flag, yes or no, and then when it was created. And just a little information about the table. The ID is an auto increment primary key field, and the created is a current timestamp field that will default to the current timestamp. So that's the data set that I want to work with in this case. Okay, so in order to do that, I'm going to exit out of MySQL. And I'm on my desktop. I'm going to create a new directory for my my Node project. So I'm going to call this Node-MySQL. And I'm going to move into that directory. And then I want to initialize my project, so I'm going to use this npm init command. And that all looks great. And in order to run this project, I'm going to need MySQL. So I'm going to go ahead and do that install right now. So I'm going to do an npm install of MySQL. Okay, looks like I'm running into a problem. npm install MySQL. Looks like it's not there. You'll notice it looks like I'm running into a problem because I named my project the same thing. This is the first time I've actually ran into this error. I'm going to go ahead and open up package.json. I'll do it in the text editor here, so I'm going to go ahead and add my project folder. And let's see if we can get this resolved. Okay, so this is the project folder. And then package.json is what I'm working with. And I'm going to call this, instead of MySQL, I'm going to call it Node-MySQL. So I think the project name was causing a problem here. And then we're going to try to do that install again. And you'll notice that now the install was successful after I changed my project name over in package.json. Okay, so just a tip, don't name your project the same thing as what you're going to have one of your dependencies be. Okay, so we have MySQL. And what I want to do is I want to use MySQL. So I'm going to have a variable called MySQL equal to require. And I'm going to require that library. I'm going to save this as app.js. Okay, and then again, so in our last video we looked at NodeMon to monitor file system changes. As we're modifying this file, I don't necessarily want to go out and call the node command every time. I just want to see the results. And I'm probably fine if I actually, let's go ahead and not do that so that we can see the updates as we go. In order to make this work, I'm going to need to be able to connect to the database. So I'm going to have a connection object. And the way I'm going to have the connection object is I'm going to use this MySQL variable. And then there's a create connection command. And the create connection command takes an object that has key value pairs for all the information that we're going to need to connect to the database. So like, what is the server name, what's the database name, what's the username, what's the password. So our server name is going to be our host, and I'm going to use 127.0.0.1 That's where MySQL is running. It's on my local machine. The database that we're using is that to-do database. The username that I have is root, and then the password that I have set up is student. Okay, so that's all the information I'm going to need to create that connection. And then once I have that connection, I can run my query. So let's say my query is simple, like select star from tasks. Okay, so no parameters or anything like that. It's just a simple query. I want to get all of the records, all of the tasks that are in that table. The way this works is my connection object that I have can then query the database. It'll take the query as a parameter. It would take parameters, but that's an optional field. There is no parameters in this case. And then the third parameter that it takes is a callback where I have an error and data that would get returned to me on success. So all I'm going to do is log the data. And I probably should handle the error. So if the error exists, then throw the error. Okay, so really straightforward exception handling. I'm going to go over to the terminal, and we should be able to run this now. So we should be able to run node app.js, and you'll notice that I get my collection of objects, and I'm able to manage that data. Okay, so these are the objects that are coming out of my database. Okay, so as long as I have this connection object, I'm able to execute my SQL statements. So for this example, what I want to do is I want to deal with persistent storage. So in our last video, we looked at creating a RESTful API in Node, and a RESTful API is going to require us to be able to select data, to insert data, to update data, to delete data, so those CRUD methods. What I want to do is I want to do the same thing in MySQL. I want to walk through those CRUD methods in MySQL, and I want to move the MySQL related code into its own class definition. Okay, so I'm going to create a new file called taskmanager.js. It's going to be a class definition for task manager. And then ultimately, what I want to do is I want to be able to export the task manager class. Okay, so that's what this file is going to do. I'm going to export this class. And then the idea would be all of this code that I have here would then end up in my task manager class. So I'm going to cut this from my application and move it over into my task manager. And we're going to have to move things around a little bit. So the require statement I'm going to move to the top before the class definition. Clear up some empty space. And then what we have here is a method to get all of the tasks. So what I'm going to do is I'm going to have a method called allTasks that doesn't take any parameters. And ideally, all tasks would return this data instead of logging it. So right now I'm kind of restricting it to say, let's go ahead and log all of the data. So I can put this return statement in here to return the data when it comes, but that data is in a callback, and that's going to cause some problems for us. So the problems that we're specifically going to have is, let's say I go ahead and define the task manager. So I'm going to go ahead and import that. And I need quotes around that. And then I'm going to create an instance of it. So I create an instance of the class. And then what I want to do is I'm going to go ahead and say, here's some tasks. I want to go to the manager and get all of the tasks. So I want to invoke that method, and then I want to log the tasks. That's the idea. Okay, so I head back over to my terminal window. I Control-C out of the application. I'm going to clear the console so we have a clear picture of what's happening. I'm going to issue the command node app.js, and you'll notice the data that I'm getting back is undefined. Okay, so we could handle this a couple of different ways. One way that we could handle it is we could make this a synchronous process. So we could say, you know, this is an async method and I'm going to await the results of this query. Alternatively, a different approach might be all tasks is going to take a callback. So I'm going to pass in a callback, and then instead of returning the data, I'm going to execute the callback, forwarding on the data. Okay, so all of my API methods, so I'm retrieving the all tasks, I'm going to have a callback, and the callback is going to get access to the data. So now if I execute this, I'm no longer logging all tasks. I'm no longer having a variable there. What's going to happen is all tasks is going to take a callback that's going to get the data. I'm going to forward it on to some function, my callback function, and that's where I can log the data. So it just looks a little different than what we're used to. Okay, so now if I come back over and I execute the same thing, so I want to execute that node app.js. Now you'll see I'm going over to the task manager, I'm getting the tasks, I'm forwarding on my callback. My callback happens to receive the data, and then we log the data. Okay, so we're able to get all of our tasks. Okay, that's kind of step one if we're building out a persistent API. The next method that we'll implement is we want to be able to get a task by ID. So we're going to send in an ID and a callback, and this method will look really similar, right? So we're going to kind of copy and paste all of this. And since we're copying and pasting all of that, let's go ahead and refactor that right now before we get too far. So the first thing we can do is we can refactor how we create the connection. So I could have a method to get a connection. So I'm going to go ahead and have just a method that's going to get a connection. So get connection. And we create a variable and we return that variable. Okay, and then now we can just use our method. So we're no longer embedding our connection information in every method. We're going to have one method where that connection information is included. We're going to use the getConnection method to get a connection in the all tasks. And then we'll do the same thing here. So we want that same exact line of code. We're going to create an instance of a connection, and we're going to get the connection from our method. Our query is a little bit different. So select star from tasks where ID equals, and I know some of you are familiar with this syntax, and it's going to carry over from JavaScript in ES6 where we can interpolate that string. So we could say, you know, I want to go ahead and take the ID and interpolate it. But really what we're doing there is we're string concatenating the variable that gets passed in, and that's pretty dangerous, especially if we're going to be talking about SQL injection attacks. And we really want to avoid that. So the way we want to handle this is we want to have a parameter there. So our statement is select star from tasks where the ID is equal to some value. Where we don't have the value defined, we want to use a parameter to define it. And the way we'll do that is we'll just put a question mark here. Okay, this is an unnamed parameter. And what that means is I could have multiple parameters that all be indicated by question marks in my SQL statement, and then I will pass values into those parameters right here in this query, and I have to pass the parameters sequentially in order. So the first value goes to the first question mark, the second value goes to the second question mark, and the way those values are passed is an array of data. So we're passing an ID in an array. So the ID comes in, we build an array, that's the one parameter we're sending into our SQL statement. It's a one-for-one match in this case. Okay. So we have the ability to get a single task. So now, if I want to run this, I can use task by ID, and I don't know what IDs I actually have, so it looks like I want to deal with this eat pizza task, so it's a task with an ID of 10. So I want to get the task with an ID of 10. I'm going to get data back, and I'm going to pass that into my callback function where I log the data again. Okay, so we come back over to our terminal, and we should be able to execute that same method. You'll notice that I get the one record that has eat pizza. You'll also notice that that one record does get included in a collection. Okay, so that one record gets included in a collection. I could come back and say that's not what I want. I might decide that I know that I'm only getting a single piece of data back. So you'll notice what I did is I changed the data. I'm not forwarding all the data onto the callback. I'm filtering it to say I just want that first record. And now if I come back over to my terminal window and run it again, you'll notice that I just get that one data piece. You'll notice that it's not wrapped in square brackets. It's kind of your preference. For ease of use, I'm going to avoid grabbing that single piece of data, even though that may be the better option. I'm going to avoid it for now. Okay, so that's our task by ID. The next thing we have to be able to do is we have to be able to add a task. And the way we're going to be able to add a task is each task has to include description and whether or not it's complete. Okay, so we're going to have two parameters, description and complete. And then we're also going to have a callback. And we're going to run this same kind of code. So we go get our connection. Our query is going to be different, but eventually we're going to run our query with some different parameters. We're going to invoke the callback with the corresponding data. So let's fix the query. Insert into tasks, description, and complete, I believe are the two fields. So description and complete, it's not completed. These values, the values being question mark and question mark. Okay, those are two parameters that are going to get passed in. And now I'm going to use those parameters in the array, so the description and complete have to be in the order of where I want them in the question marks. So we're going to pass that data along. Okay, and then we'll execute our query. Okay, so far so good there. Again, we just copied and pasted everything. So instead of copying and pasting everything, what I want to do is the stuff that I copied and pasted, I want to move and abstract into its own method, just like we did for the get connection. So let's go ahead and have a method called run SQL. And the idea here is this run SQL method will take an SQL statement, the parameters that need to execute, and the callback. Because the callback will be different across all of these methods. Okay, so we no longer need this query because it's going to be passed into us. We are going to need to get the connection. We are going to need to query the connection based on the SQL statement that came in. The parameters are going to be our array of data, so we'll pass that along. And then we're going to invoke the callback. Okay, so we've abstracted all of this away. So if we're looking at it, we no longer need a connection. We no longer have to handle all of this data. We're just going to have our query, and we should be able to call this run SQL method. Okay, the run SQL method takes the SQL as the first parameter, our query, takes parameters. In this case, there are none, so we're going to leave it as undefined, and then we're just going to forward on the callback. And then we're going to use that syntax to handle all of the rest of them. Okay, so we're going to run our SQL statement, our query. The parameters that we want to send are just the ID, and then we're going to forward on the callback. And then the rest of this can go. Same with add task. We no longer need a connection. That's going to be handled in our run SQL. We do need our query, but then we should be able to call run SQL passing in our query, And then our parameters are the description and whether or not it's complete or not. So we'll use those, and then we'll forward on our callback. Just clearing up some white space. So at this point, we're going to have 3 methods, all tasks, task by ID, add task, and then I want to test the add task method. Okay, so I'm going to go ahead and add a new task. So I'm going to go to the manager, I'm going to call the add task method. It takes a description. So the description might be mow the lawn. And then I have to pass in a completed flag, either 0 or 1. And the idea here is that I also need a callback to handle the data that I get back from this. And the data could be a lot of things. It might be the new task, but I'm just going to go ahead and allow for the data. If I go back to the task manager, you'll see that the data that we get back is from that query, and this may or may not be the data that you expect. Okay, so as we try to add a task, so we're trying to add the task mow the lawn, and you'll notice the data that we get back is an OK packet. It tells me that there was 1 row affected by this. And if I were to look at MySQL, I would see that new task. Instead, what I want to do is, I know the add task method is working, life's good there. What I want to do is I'm just going to take a look at our all tasks method, because we have made changes to it, and I want to go back and verify that those changes didn't break anything. And you'll notice here that we are seeing our additional task, which is mow the lawn, that was just added. Okay, so we were able to add a task into the database. This is persistent, it's in the MySQL database, and we're able to add that new task that we tried to add. Okay, so the next thing we're going to have to be able to do is remove a task. Okay, so when we remove a task, really what I need is an ID and a callback method. And our query is going to be pretty straightforward. Delete from tasks where the ID is equal to some value. And then we're going to run our SQL statement. We're going to use that method that we built to take our query, our data, our parameters, and then our callback is going to get invoked on the callback that executes in the run SQL command. So we're going to get our callback, we're just going to forward on to our run SQL method. Okay, so we just added a task to mow the lawn, which had an ID of 11. What I want to do is I want to keep this code to show all of our tasks, but it's really more of a verification so that when I remove a task, I can verify that the task was removed. So I'm removing task 11. I'm going to get confirmation of it with the data. The data is going to look really similar to what the data looked like when we inserted the record, in that it's going to give us a confirmation based on the number of rows affected. Okay, so now if I come back over to the terminal and I execute our application again, and that does not look right to me. I was thinking that this doesn't look right, but there's a couple of things going on here. You'll notice that the callback for all tasks completed before we removed our tasks. Okay? I'm not convinced that that task isn't removed. So if we go back over to our terminal, you'll notice that it says that there was 1 row affected. Okay, so if I run the same thing again, you're going to notice that mow the lawn was removed. And now if I try to remove it a second time, and you'll notice the order changed, the number of affected rows is 0, and the order changed in the way the callbacks occurred. So I could nest callbacks if I wanted to, but I'm pretty confident that the remove task method is working as defined. Okay, so we're able to remove tasks. And then the last thing that we're going to want to be able to do with our API is we're going to want to be able to update tasks. So I'm going to go ahead and have a method to update a task. The idea is you'll send an ID, and I'm going to allow you to change the description. Well, actually, let's not allow the user to change the description. So update is always a tricky one. Like, what am I allowing the update to happen? So I want the only thing that can be updated is whether it's complete or not. And then I'll have this callback. And the idea is that my query will be update tasks set complete equal to question mark, where the ID is equal to question mark. So I have two parameters in this case with my query. I can go ahead and use the command that we built, the run SQL. It takes our query, it takes the parameters. So in this case, the parameters that came into the method update task are not in the same sequence that we want to pass them into our SQL statement. So I have to be careful of that. I want the complete parameter first and then the ID parameter. And then we'll just forward on our callback. Okay, so that's our update task. We'll bring that back over to our application. And if we're looking at our application right now, instead of eating pizza, maybe I should mow the lawn. So I'm going to call the update task method on record 10. And I want that, and I guess, again, I misspoke there. If I'm looking back at my data set, eat pizza right now is not completed. I want to mark it as complete because that's the only thing that I can update. So the completed, I'm going to send in that flag, and then my callback is going to be a callback where I get data and I log that data. Okay, so my update doesn't allow me to actually change the task description, and that was by design. And then I come back over and I'm trying to use the API, and my first reaction is I want to update the description, but that's not the way we built this. Okay, so we're updating the task, just marking a task from complete to incomplete or vice versa. I can change that status. I'm updating the task. I head back over to my terminal and I can execute my code, which will trigger an update. So you'll notice that there was one row affected. Okay, you'll notice the complete flag did not change, but we should be able to go out to the database and verify that that change happened. So if I use the MySQL-u root-p student, and then I use my database to do, and then I select star from tasks, you'll see that that complete flag is changed, okay, from 0 to 1. So our update task is working appropriately, okay? So this is kind of our test harness that we're using for all of these different methods. What I want to do is I'm just going to comment all of this out for the time being. And let's say we were trying to build out an API that had persistent data. In order to do that, I'm going to go back to my terminal, I'm going to exit out of MySQL, and I want to use Express to do that because that's kind of the tool of choice. So I'm going to use the npm install Express. Okay, so Express is there. I want to use that, so I'm going to require Express. So I will put that at the top here. Const express equal to require express. I'm going to build an application. And then that application has to listen on port 3000. We're going to get a callback, and that callback will then execute. So we'll log that we're listening on port 3000. Okay, that's the start. We can verify that that's working. Okay, so it says we're listening on port 3000. If you go back to our last video, when I go to port 3000, I can't get the root of the website because I don't have a path defined for Express. So what I'm going to do is I'm going to say, I want to listen for our API. So we're listening to a specific URL, sorry, not app.listen, I'm going to use app.get. I'm listening for a specific URL, so the URL that I'm listening for is api.tasks. And when I do that, I want to get all of the tasks. So I'm going to get the request object, the response object, and I have to define what should happen here. Well, what I want to happen is I want to go to the manager and get all of the tasks. So I'm going to get all of the tasks, I get the data, and instead of logging it to the console, I want to send it to the browser. So I'm going to go to the response object and send JSON back based on the data. Okay, so then we don't ever define this route. So this route, where you just go to localhost 3000, is not defined. However, we do have our API route now. That's defined. So if we go to our API and ask for all of the tasks, now you can see all of the tasks from that tasks database. Okay, so I'm not going to go through the process of actually wiring up the get, the post, the put, the delete, but all of those methods we looked at building an API, so you can look at those, and then they'll tie into our task manager CRUD methods. And that allows us to have persistent data for our API.